Hi everyone. So first I'm gonna show. So some of you may have seen uh, all the fluid research uh, I was doing. So this sort of thing. So this was done using the NVIDIA Flex library, which I brought into Touch using the C++ operators. And so another thing that's possible with this library is to simulate soft bodies. So this is all dynamic. So just to show you quickly, so you can see you get like a nice inertia distribution, and so this, and I can play with gravity. And the nice thing is that everything is colliding, so you don't get uh, any artifact of things intersecting. So the way it works is it's also using particles, and so this is what the simulation is running on. Just kind of, and so I continued using this library because first I had already like a framework set up for the fluid simulation. And also, ultimately, the kind of cool part is since it's all like particle based, the fluid can also like push this around, but that's going to be a next step. And so one thing I was interested in for this was to leverage touch node-based environment, but still like bring entirely new features like this. So the way the system is working, just gonna like this. So this is kind of my so you have the first operator, which is gonna turn uh, this just like typical mesh into a point representation. So not if I show. And so the way the simulation works is that at the same time clusters are created, and each cluster of particles is going to try to keep its shape, and this the the motion of these different clusters with some constraints which like gives the final deformation. So here, uh, so I have like a little visualizer to show like, so each red is like one cluster, and besides the particle, it also creates uh, like these are the cluster center. So what I get out of the simulation is both the new particle position and this position, and then using a shader, I can then skin my input mesh to get the deformation. So the other cool, yeah. So my second C++ operator, oh yeah, so just to show you quickly this one, just gonna show again the particles. So for example, I could use volume sampling, and now instead of just turning the surface into particles, turning the actual volume. And so if you go finer, then get this sort of thing. So since the simulation is still kind of expensive, for like bigger scale, like I just simulating the skin is enough, which is what I did in the sample. And then I have this second job, which is to which I feed both the cluster center and the mesh I want to deform. And since all the deformation is going to happen on the GPU, I can have like a pretty dense mesh. So I could even have like more detail. And then all of this is to I'm using subs to like select so yeah, just like all these parameters to like define which of the points are gonna follow the input animation and which of the points are gonna be simulated. And then I feed all this to this guy who's the actual solver with the parameters. And so it's all yeah, and so out of the simulation I get the just gonna show you this thing. So this is what's used to skin my to deform my input mesh, and all the magic happens in this shader, which just transform the input points using this. And the other cool thing, so as you could see, I was only creating one tentacle, and then I'm using instancing to duplicate those. So in the solver actually simulates everything, but then for the rendering, it's just one mesh that's being instanced. So that also keeps it pretty fast. So I'm just going to show you back the so since change some parameter I'm resetting. So just to just to show you just turning the wireframe so you can see that. Then the so building on this, just showing how you can simulate multiple. Oh yeah, and so at the first frame of the simulation, it's gonna use this table to kind of know which is gonna be simulated. And so I prepare another one. And so if I add this guy and restart, and okay. Oh yeah, because I was still. Yeah. And so this is just like really simple. So it's kind of a crappy mesh because it was just so I just created inside of Touch like a simple head system and used the wire operator, and so this like gets the same treatment, gets turned into okay. It gets also turned into particles somewhere. So another feature which I already have is so do some interaction with like a little force field. And just I'm sorry, just like a simple rendering. So that's it for this. So I feel so I'm kind of so it's kind of not too bad to, it would be great if Touch SDK would become more open. One thing I wanted to show is that so the way I'm bringing the geometry into the C++ operators is I need to convert the points and primitives into that, and then these tables get read into there, because there's no, like, this is like a pretty tiny word and doesn't have access to any of the scene. So it's like all these kind of tricks to do everything with chops. Okay, so I'm still pretty super happy with like where I got, and like it's now it feels like pretty usable. So I'm gonna start using this. Okay, and now more of a small small tutorial on geometry shader, which is also more advanced, but I feel it's kind of a little known feature and not super documented into the documentation. So, okay. So here's a wonderful torus. So how, so if I create a simple form and I like output the code, so you will see there is this mysterious white box here. So what can you do with that? So if you Google online, you can find a very basic shader. So a geometry shader is so it has a inputs and output. So for each of the input primitives, you can create output primitives. So the pass-through is not doing anything. For each vertex, it just emits the same vertex. But however, if I plug this guy in, so my torus turns black, and that's because so all the vertices attributes that are required for shading, so the color, the camera space vertex, the camera space vector, and the normal, you actually need to pass them through the geometry shader and then back into the pixel shader. So I just modify the first shader to do exactly this. So this is pretty similar, except I'm copying the input attributes to the output vertex. So then something a bit more interesting. So one of the nice thing about the geometry shader compared to typical vertex and fragment shaders is that um, instead of just being aware of itself and none of its neighbor, uh, inside of a primitive, so a triangle, you have access to all 3 points. So for example, you can recalculate normals inside of the shader. So the way this is done is, so you take the 3 input points. So you get this array gl-in, so 0, 0.1, 0.2. And you calculate, so 2 vectors on the plan. And then the cross vector is going to be the normal. And then you just replace the existing normal with this new normal. And then, yeah, so the nice part about this is that if you like have some deformation going on inside the vertex shader, so here I'm just gonna apply a Perlin noise. So you can see so of course it's like gonna be faceted, but you can see you have like purple lighting because the normals are recalculated. And the nice part is it's all happening in the shader, so I can have something much denser, and it's still like just as fast. So I'm gonna turn the noise off again. Also using the primitive center, you can do some classic motion graphics like scan and dissolve effects. I'm gonna go back to small. So here what I'm doing, yeah, one thing I skipped a bit fast. You have to be aware of the which transform space you're in. So traditionally the vertex shader, so this function tdcam to proj is gonna go from world space to projection space. But for all this deformation, you kind of want to stay in world space because the coordinates you get, but yeah, because the coordinates you get are gonna be deformed otherwise. So instead of doing the whole transformation in the vertex shader, I just output the world space position, and then the final transformation is happening inside of the geometry shader. So for this, I was just scaling using I was just pushing along the normal using the center, the normal I just computed. And then if you like, just kind of go through this one. So then you can, so using, this is something you get in the shader, which is the primitive number. So just using this number, I can do some nice dissolve effects. And now I just need to, so if I sort the primitive by x, now I'm gonna get this like classic like little effect. So this is the kind of techniques that I was using on this. So just some like VJ core apparition effect. This is a render, but I could show it in the I think it's still so this was originally some research for the Deptfire show, some of the real-time effects that were done in Sandbox.
So this is kind of how it.
Yep, sure.
So you said that the main difference between the geometry shader and the vertex shader is that on the geometry shader you have access to the whole point array.
You have no, not the whole geometry, but just the geometry from the triangle.
That's just the primitive.
Yeah, the primitive.
Which allows you to calculate the normal on your own.
Yeah.
And then,
which, like normally, like the vertex and fragments, everything's parallel, just one point.
Can you generate?
So yeah, this is just showing the. So same thing with like noise and a bit more effects. Yeah, maybe I'm just gonna go through everything and then we can ask questions. So the second thing that's pretty cool with geometry shaders is to create sprites from particle. And this is actually pretty straightforward. No, this one. So, oh yeah, so the thing that's different for this one, you have to choose points as the input primitive type. And I think touch will only send points if you have a particle system as an input. So I'm just converting the torus into a particle system to get the proper input for my points. So yeah, so the kind of nice thing is when you're in camera space, so camera space is the transform space oriented from the camera. So Z is like always like going in the depth, Y vertical, X horizontal. And so when you're in camera space, I can just like create my 4 points, and it's gonna be like 1 1, minus 1 1, minus 1 1, and it's gonna create these little squares which are always gonna be facing the camera. So here you can see I stayed in camera space, and then it's only at the end of the geometry shader that for each point I'm going to transform into the projection space. So projection space is kind of similar, but you're gonna get it's just like a flattened version of the camera space. So you're gonna get like rectangle because the aspect ratio is gonna be wrong. And then I build just a yeah, just a like just a little scale. And also the interesting thing is it's still inheriting the normal from the mesh. So if you, so it's kind of like point rendering sort of thing. So far so good. It's still pretty close from what you can do with point sprites, except at least it gets scaled properly in the depths. But then the other, oh yeah, so before I get to that, so you can also create UV coordinates, which I did in this version. So instead of just offsetting the input position to go to the 4 corners, I'm also, so in input there is no coordinate, and in output there is the texture coordinate. And so I'm just going to do 0, 0, 0, 1, 1, 1, 1, 0. and this way I can map little, oops, that's so I can see that one. Quick tip. So I was using just to say it in the viewport, this got pixel based on alpha, because if you don't and you do blending, then you're gonna either you turn off the depth test, and then like you're gonna have some stuff which is in front and actually be in the back, because for proper alpha blending you have to sort the particle from depth to front. So if it's so just a quick way to solve this is to use this, which I think Brandon already mentioned when he was doing this too. And then another quick tip. I'm just going to zoom this guy. So just to get a better anti-aliasing, you can turn on alpha to coverage. So this is using multisampling to kind of render only a percentage of the pixels on the edge. So this way it also like prevents you from having to sort stuff in space. But so the really nice part is you can, if you have like a particle system, you can use the input velocity to orient and stretch your sprites. So I'm just using a trail to add the velocity on the torus. I can also use an actual particle system. Oh yeah, so just a quick note, just for scaling reason, I was multiplying the velocity from the trail by 1000, and you can see this is like 2 milliseconds, but I'm doing it in Descript, and if you do this in Python, now it's like 10 milliseconds. So whenever you can, I would suggest to use Descript, because Python is still very, very slow. Oh yeah, and what I wanted to do was to plug the actual particle system. So now you can see that also so little fireworks of one, like nicely oriented and stretched. So just to quickly go through the code. So with the So in my particle now I have a V attribute, which is the velocity. And now inside of the vertex shader, I can use in V, which is gonna read this attribute. And I'm just gonna transform it into camera space and pass it to the output. So this happens here. And then inside of the geometry shader, I just use this direction and the perpendicular direction to kind of like extrude the quad, which is going to be oriented. And also it's going to scale the quad based on how big the velocity vector is. And one last note is that the output is a triangle strip. So it's a bit less intuitive than like a typical graph. But you have to like pay attention to like the order of the points if you want the two triangles to, because you're only emitting one primitive and 4 vertices, but it's actually going to create 2 triangles. So here you can see that it's going to be 1, 2, 3, and then 2, 3, 4, 2, 3, 4. So, yeah, and that's it. So I think there are other like interesting techniques with geometry shader. Like you could like do extrusions or like create outlines. Like there's a bunch of resources. So I think it's really useful for like. Oh yeah, one last thing. So actually I remembered that, yeah, the next step. So in the still fairly recent particular GPU example. Right. So you can see a geometry shader is used to create this. And there is some additional code because each of the parts rotates to give like this nice, I'm gonna make it so yeah, I would recommend looking at this sample, which is like very good resource for improving your GSM knowledge. So yeah, some more advanced topics to spark curiosity. I don't know if you have any questions. Yeah.
Yeah. So basically, the geometry shader, you can also generate new geometry.
Yeah.
Right.
Yeah, you can also you can generate triangles. You can also generate lines. So for example, another use, like the classic like connecting points based on distance, like this could be recreated in the geometry shader and like be much faster than like the CPU version.
But then how do you do that if you don't have access to all the points? You say that you don't have access to like each triangle. How can you get the whole array of the object?
Well, you still inside. I mean, you can still like pass like a chop with like all the and I mean, I guess it's like if your input particle system is on the GPU, then you can also feed texture to your shader and look up all the other points position inside the texture. That's kind of like similar techniques. I think Matthew Reagan posted on the forum like a trick to this to do voids. And so inside of the if you go back to this sample, so this is like a float texture which like each point is like the RGB or the XYZ coordinates of a particle. And so when you do the simulation, you can look up any point, so you can like loop around on all the points. So you could like do something similar in the geometry shader. The only thing is the geometry shader, it's only good to emit a few primitives. I think if you create a ton, then it's like not so great on performance. But, so yeah, I think
back like on the fluid stuff you're doing, every time I've done fluid things, it's been more traditional 3D modeling packages where generally it's so computationally heavy that you're not getting any sort of real-time playback or preview of any sort, other than keeping in performance just because it's running on the GPU versus
Yeah.
CPU?
That's the that's the main interesting part about the new NVIDIA libraries that they run on the GPUs. So on fast GPUs, it's magnitude faster than like traditional.
And perhaps for the simulation, how accurate of a simulation in your experience does it seem to be? Like, is it like sort of a true like computational fluid dynamics level stuff, or is it sort of like a sheet using particle soft body thing that
It's-
seem to look like
I mean, it depends. It depends how big you want to scale.
Sure.
But like for a smaller scale, like you get some very lifelike results. Like it's not gonna be like movie quality
Sure, of
for
course.
sure,
Obviously, it's not real fun.
but like I can just very quickly.
Have you seen the NVIDIA demos that are on the website for Flex? 'Cause those show off like really high level shading and stuff. And they have the cereal bowl example where things are spilling and like reacting very realistically. Actually, that's really cool.
I will for sure get that.
So this is not that many particles, but you can get nice results.
Works on
Just to so for this, yeah, I think I'm going over my time. But yeah, I can. Just some samples. Oh yeah, so this is something for Ben. Like sometimes my references are lost. I'm not sure why. So I'm gonna try and restart, see if that fixes it, because sometimes it does. Yeah. Replacing. Yeah, I need to. Yeah, so I need to check my reference. Okay, thank you.